Right, so to talk about each wire on its own, there are 3 wires, but really there's only 2 of them which are necessary for the circuit. And those 2 wires are the live wire and the neutral wire. So the live wire is the wire which carries a current which alternates from positive to negative. That current is called alternating, and you already know that, or AC. The neutral wire then. Now, I'll show you a circuit in a second, but the neutral wire is necessary so that it completes a circuit. And so you'll actually find that coming from the power station, you only have 2 wires. There are only 2 wires, live and neutral. So the live one is the one which carries a current, but the neutral one is there to complete the circuit and to allow electricity to flow back to complete the circuit. So the neutral wire stays at a voltage close to 0 with respect to earth. What that means is that you know that you need a battery to push current around the circuit. And the reason you need a battery is because you have a difference in potential. So you've got a plus and a minus in the battery. And it's that difference in potential that gives the current energy to move the charge around the circuit. With the mains electricity, we need kind of the same thing. So we need a live wire which has got a high potential, and then the neutral wire which completes the circle is at a very low potential, almost 0. And that means that gives the circuit energy to push the current around the circuit. So we wouldn't obviously draw a battery in our main circuit, but this is the same idea, that you have a neutral wire which is a very low voltage, very, very close to that of earth. That means it's very low compared to the live wire, and therefore that gives the energy to push around the circuit. If you touch the neutral wire, you would come to no harm, because there's no current would flow through you to the earth, because it's got such a low potential anyway. So you're safe. If you touch the live wire, however, you're not safe, and you will complete a circuit to the earth and you'll get a severe shock. What colour is the neutral wire? The neutral wire is blue. And the neutral wire is connected to the neutral pin, which when we looked at the back of the plug, it was on the left-hand side. If you turn that plug round, it's actually on your right. Okay, so now this shows you a metal appliance. We'll pretend it's a cooker, say. And if the metal appliance has a case, it needs to be earthed. So coming from your power station, you only have these 2 wires. But whenever we connect our plug into the socket, we actually need a cable with the 3 wires on it. And those are the 3 wires, live, neutral and earth. And the live wire has a fuse in it. Now, this is the reason. If there was a fault and the live wire somehow came loose from wherever it was connected inside your appliance, and it actually touched, or some part of it touched the outer case, like that. That would mean if you came along, if a person came along here and touched the case, then the electricity would flow down through them, down to the earth. There's the earth. And that would really give them a very, very nasty shock. Okay? Now, to prevent that happening, what happens is we connect a 3rd wire. And that 3rd wire is only connected from our socket to our appliance. From the socket, it's then connected to the earth somewhere outside, to a large plate under the ground. So near the house somewhere, there'll be a large earthing plate or something metal under the ground, which will have the earth wire connected to it from the socket to the outside. And that means that when when the live wire, the fault occurs in the live wire and it touches the case, the earth wire, because it's connected here to the metal part, what will happen is the current will flow through here, and instead of going through the person, because a person, despite the fact they conduct electricity, they have a fairly large resistance, the current will see a path of much less resistance through the earth wire, and it will flow very safely through the earth wire. Now, because the earth wire has a very low resistance, a very large current will flow, and this will blow the fuse. That will break the circuit. the person's safe. Even though the person's touched the case, they didn't even know it was live because of the fact that the earth wire has carried the current away safely. So all they will know is that their appliance isn't working. So there are really 4 safety features which either protect us or protect the appliance. The first one is the fuse. Now, the fuse blows when too much current flows through it. That will protect you if that too much current is a little current, but if it's a large current, that won't protect you. So the fuse only protects the appliance. So that a fuse in an appliance might be up to 13 amps. 13 amps is a huge current and could easily do you lots of damage. It will protect the appliance, the fuse will blow and the appliance will be protected, but that may not necessarily protect you because 13 amps is a very large current and it could cause you a lot of harm. The earth wire is the main thing which protects the user. And it's the wire which carries the current away safely whenever there's a short circuit within the appliance and current's allowed to flow through it. And that usually blows the fuse. A circuit breaker. A circuit breaker protects the appliance and the user. It detects how much current is entering and leaving the circuit. If there's a difference, the circuit breaker trips and breaks the circuit. Now the last thing, which isn't mentioned very often, is something called double insulation. And double insulation protects the user. This means that there's a double layer of insulation between you and any metal parts of the appliance. In this case, the appliance doesn't need an earth wire. You will never be exposed to something which is metal and therefore you can't get a shock from it. And you'll see sometimes in a question exam, they'll show you some kind of circuit and there's only 2 wires connected. And when they say that, that means that it is doubly insulated. And there's a symbol for double insulation, and it's 2 squares, one inside the other. So a little bit more about fuses.